Hello students, let us discuss a question on collisions and center of mass chapter. So this question appeared in previous JEE mains question 2024 question. So this question is not exactly from the collisions topic, but it is somewhat related to the collisions chapter. It is actually from the modern physics chapter, pressure exerted by a radiation topic. Okay, so first read the question. If the total energy transferred to the surface in a given time is given, then the magnitude of total momentum delivered to the surface for complete absorption. So that means if a radiation incident on a surface, so this is the surface, some energy is incident from here. So two cases can happen. It is completely absorbed, it is reflected back, it is reflected. Something like you can think of a ball is coming and absorbed here, sticked here, the same ball is again reflected back here. So when it is completely absorbed here, its final momentum will be 0, then whatever the initial momentum will be p, then final momentum will be 0, then change in the momentum is simply p here. But here it is initial momentum is p and final momentum is also p, assuming perfectly elastic collision, then change in momentum comes out to be 2p. Be careful because it is a vector, the sign will be there. So, but how we can treat energy as a particle just like a ball? We know that light is a collection of photons. It is a photon energy. It is a photon energy. That means photon can be treated as like a ball. It is coming. So what is the linear momentum of that photon is given from de Broglie idea. So the de Broglie's concept will be linear momentum P is equal to h by lambda. Okay. Then how this lambda is linked with the energy? So again, from the Max Planck hypothesis, energy will be is equal to h nu for a given photon. It will be hc by lambda. So the lambda will be is equal to hc divided by E. So that means from these two relations, I can write for the linear momentum P will be is equal to h divided by lambda means hc by E. H will be cancelled. So linear momentum simply P is equal to E by C. So linear momentum and energy are related like this. Just remember. So when it is completely absorbing, the change in momentum is simply P. When it is completely reflecting, the change in momentum will be is 2P. Okay. So therefore in my case it will be completely absorbing, the change in momentum will be is equal to simply P, that P is equal to E upon C. So then if substitute here, E value is 6.48 into 10 power 5, C value is 3 into 10 power 8. So that means the answer comes out to be 3 1 ja 3 2 ja. So 3 1 ja 3 9 ja into 10 power minus 3. So 2.1936 ja, sorry, it is 36 ja. So 2.16 into 10 power minus 3 is the right answer. So I suggest you remember these formulas, it will help you even further. Even the same answers I can represent for a radiation pressure. The radiation pressure, even you can call it as the energy density or energy density. So for completely absorbing surface, radiation pressure or energy density will be is equal to simply intensity divided by speed of light. For completely reflecting, so radiation pressure or energy density will be is equal to 2I divided by C. Okay. So remember what is the meaning of completely absorbing surface and completely reflecting surface, how this radiation pressure is related. Once I know the pressure, even I can calculate the force also. Look what I can calculate the force. Force will be is given with pressure is force per unit area. From this force will be is equal to pressure multiplied by area. So don't confuse the difference between the pressure and the linear momentum. Okay. So these all things I am discussing here, linear momentum. If you want, you can take the small p here. Small p. Small p means it is for linear momentum. Okay. Be careful. Okay, this is very important topic. Generally questions will be asking in the JEE, even JEE advanced, NEET examination questions. Okay, they will frame a question from this topic. I hope it is clear. Thank you for watching my channel. Please subscribe my channel and share to your friends.